Hello everyone, welcome to my channel. Today's topic is how to make thermal paste at home. So what's thermal paste? Thermal paste is one of the thermal interface materials. Thermal interface materials are used to increase heat transfer by filling the gaps between two surfaces in contact. The heat generated by the CPUs in our computers is removed by heat sinks and the CPU is prevented from overheating. It's essential to use thermal interface material, the CPU and the heat sink contact surfaces. Desired features of thermal pastes should have high thermal conductivity, low electrical conductivity, be easy to apply and penetrate into gaps, not decrease thermal conductivity over time, and should not leak. After this summary information, let's come to our own project. We will use two materials to make thermal paste. The first material is graphite powder. The second material is glycerin. As for graphite powder, I recommend the ones used for painting ultrafine graphite powder with a grain size of less than 50 micrometers. You can also easily obtain pure glycerin from pharmacies. The graphite powder and glycerin I use are not toxic substances. Why did I choose these materials? Glycerin is a liquid with relatively high thermal conductivity and its evaporation is very low. Its thermal conductivity is 0.285 watt per meter Kelvin. Graphite powder is a material with very high thermal conductivity between 150 to 300 watts per meter Kelvin. The mixing ratio of graphite powder and glycerin is important in terms of the properties of the thermal paste we will make. While the increase in the glycerin ratio has a positive effect on the filling the gaps, it will also have a negative effect on leakage and total thermal conductivity. In this experiment, I tested a lot of different ratios of graphite powder and glycerin mixtures, and I want to give you the best mixing ratio I found. I'll show you how I made the mixture and measured its thermal conductivity. I'll use a setup like the one you see on the whiteboard behind me to measure the thermal conductivity of the thermal paste. Here, a thermoelectric module will be used as a heat source. The amount of heat will be obtained by measuring the electrical power supply power. The thermal resistance will be calculated from the heat and the temperature difference it creates. The mixing ratio to be tested is 5 grams of graphite powder and 7 grams of glycerin. We will mix these two substances well in a small cup and then apply them to the measurement surface and measure the thermal conductivity at 3 different heat flow values. The second stage of the experiment is to measure the electrical resistivity value. For this, a 1 cubic centimeter sample will be used. The electrical resistance will be calculated as a kilo ohm centimeter. Another important issue is that the thermal paste does not leak over time. For this, the sample we produced will be compressed between two surfaces in an upright position and kept for 4 days. White papers will be placed under them to check whether there is any leakage at the end of the experiment. Now let's start our experiment. The thermal conductivity of our thermal paste mixture was calculated as 1.73 watt per meter Kelvin. It is seen that the thermal paste we produce has a better conductivity value than some thermal paste sold on the market. When we look at the leakage results after 4 days, we see that no leakage was detected. When we look at the electrical conductivity test results, we measured the electrical resistance value as 6.7 kilo ohm centimeter, and we can say that it is in the low risk group and is suitable for use. However, the grain size of the graphite powder you use may change the results. Finally, since graphite powder has a serious staining capacity, I recommend that you be careful not to spread it around during application. I hope this DIY project will be useful for you. I would be very happy to see your comments and suggestions. If you like this video, please subscribe to my channel and don't forget to like it. Thanks everyone. See you in other projects.